GenZero is a research project from the DFE supported by NMITE UK, which focuses on net zero carbon in operation and net zero carbon in construction.
So it started off looking at really a way of ordering secondary school construction, a way of establishing a new standard for secondary schools, a sort of prototype basis for all of the new schools that we built, looking at something which was ultra low in carbon, a standardized system, a platform system, something that could be repeated elsewhere. And from that, it's grown into something that's very, very much larger, but reflects, in a sense, developments in parallel by Cabinet Office, for example, to try and spread this across wider government organisations. I was lucky to be part of the project right from the start, so when we started conceiving the idea and when we were applying for funding, and moved into the position of not only in a sense being the lead DFE architect on it, but also, I guess, the day-to-day lead for the whole project.
Research carried out within our team gets taken forward and reviewed every 6 months by internal and external specialists, looking in ways how we can tackle climate change and how building design can assist in reducing the overall carbon emissions associated with the construction industry, which we then put forward to the relevant stakeholders and ministerial teams so that we can drive that forward and get it into policy.
Every few years, we renew our specification in a wholesale way to reflect changes in both procurement, the way that we buy schools, and the way schools spend their money, and also to reflect sort of changes in school construction and environmental changes.
This is a full-scale prototype classroom that we had initially developed to test a kit of parts and to test if we could use homegrown mass timber.
It's certainly the case that some of the traditional materials that we construct buildings with, things like steel and particularly with things like concrete, it is almost impossible to recover the carbon position after we've used them. So very heavy use of concrete, for example, is very, very difficult to offset or to balance against ultra-low operational carbon. If we can look at the volume of materials we use and the way we use those materials, the effect of managing embodied carbon will potentially be far greater than the effects of managing operational. So by building in timber and by maintaining that timber and not destroying it at the end of its initial use really, really adds value to the construction system. As trees grow, and children have known this for years, they take on board carbon dioxide and they store it in the mass and volume of timber. And it's only released when that timber is totally destroyed, either through burning or through rotting down. And that sort of timber store and that unique element of holding the carbon into the volume of the timber is so, so valuable. And we call that sequestered carbon.
These are commercial forests grown for timber production, which also give multiple benefits while they grow, from water attenuation, cleaning the air, biodiversity, wildlife, amenities, but also a crop of timber. Now, if this classroom is taken apart at the end of its classroom life, then these products can be reused. And so we call that a cascade effect.
The other valuable bit about timber, of course, is it's a really, really tight loop. So just as we're harvesting that timber to be used in a building, in the 60-year or 80-year period that a school will survive, the trees that are needed to replace that school will come to a degree of maturity so that we can harvest them again. And that, in that respect, is absolutely unique.
This structure incorporates cross-laminated timber, often shortened to CLT, and glue-laminated timber as ribs in the floor under the CLT. Cross-laminated timber is glued together in an odd number of layers, so 3, 5, and 7, and they're 90 degrees to each other. What that gives you is enables you to span in 2 different directions. So this is what we call engineered timber or mass timber. Glue-laminated timber is glued in the same orientation. So it is parallel. That gives you bigger dimensions, so to enable you to span more. By joining them both together, you get the best of both products, and you don't overuse the timber.
The research finished mid-year, and we were very lucky then to have some funding come forward to build what felt at the time to be about 2 or 3 panels of the classroom. So we could sort of start understanding what a floor panel and a couple of wall panels would feel like.
I became involved to have the classroom prototype manufactured. ECOsystems Technologies engaged with the current consultants which were already on the project to refine the detail and perhaps pick up anything that had been missed, and to bring together lessons learned from the desktop design research that we had to what was actually possible on site. The challenge we had was to have it ready in time for COP26.
So this isn't a pure panelised school system. It's not made up of necessarily just large, very simple slabs of CLT. This is more effective, it acoustically performs better, we hope it performs better in terms of fire, but it also relies, where it is sensible to do so, on a glue laminated timber frame. All the time thinking, what's the most effective structural and simple and low material use by volume that we can achieve? And we ended up with this. So it's a system that has timber on its wearing surfaces, because we know that works best. Removes the plasterboard out of the system and just relies on a little bit of gypsum material in some of the wall product. Because this can stack 5 stories tall, uses a bit of glue laminated frame so that we minimise the size of the structural elements. That led us to putting in a concrete and timber hybrid floor, polished concrete on the wearing surface with the expectation that you do very little to it over 30 to 60 years, which I think is extraordinary. We made that concrete 80 millimetres thick, so it's doing really effective things in terms of acoustic, in terms of fire, and in terms of providing a really sensible wearing surface for a classroom. But at the same time, it's supported by timber. And we've moved away from, say, 200, 250 millimetre thick concrete slabs in what was described by Cambridge University as a unique arrangement, a novel arrangement, into a structure that pushes timber but gets the very best out of concrete.
For green skilling, part of what we're doing here at CAT, the Centre for Advanced Timber Technologies, is introducing a course called TED, so it's Timber Engineering and Design. And what we're doing is bringing in architects, engineers, designers from across the industry to be upskilled and reskilled using timber. The GenZero unit being here at CAT is absolutely perfect. It represents everything that we're trying to teach here is about using homegrown resources and utilisation of more timber. It's also off-site construction, modular construction, so it's all providing a good frame of reference.
The prototype is a demonstration vehicle. In a way, it's there to show to a lot of people what a sort of plans and elevations and sections are like in 3 dimensions. You could use it, you could see what it feels like, gives you a great sense of space and colour. We're working on what we could, I suppose, consider Mark 1 of the real version of GenZero, and we've extracted 2 or 3 teaching spaces out, and we're building those now.
GenZero focuses on creating healthy environments for school children that also addresses the net zero carbon by 2050 climate targets. It's really important that children are mindful about climate change and that climate education is embedded into their curriculum. One of the ways that we can ensure that happens going forward is to provide healthy, sustainable buildings for the children to learn in.
There's plenty of studies out there to suggest that exposed timber reduces your heart rate, increases concentration for children.
Biophilic is interesting. It's a new and emergent area of understanding, and we're doing work elsewhere outside GenZero to fully realise and understand the impact. Making the green spaces, the open spaces work very hard for us, bringing SUD, sustainable urban drainage, to the surface to create rain gardens, the cooling effect of trees around the buildings, removing sort of hot black tarmac areas and putting them away from the main sort of intense parts of the building plan. Arriving at school not through a car park. What we realised is that by doing those, we actually created a better space for children.
We have been able to demonstrate that the kit of parts is successful. Off-site manufacture does work. We just need to work with other external stakeholders and other government departments to develop this and to make sure that we're all aligned. We are in discussions with DEFRA in relation to what the supply is of homegrown mass timber and what that could look like.
The core relationship was formed around the DFE and Bob MacDonald, who were our technical advisors and lead advisory consultants and project managers. And they assembled around them absolutely high-performing team of Lars, Bills and Young as architects who had worked before on some of the sort of standardisation and spatial work with the DFE, but this was a major step forward in a sense in that relationship on working on some sort of big architectural pieces. Smith & Wallwork, whose understanding of timber and structure was beyond anything that I'd experienced before, and they'd done a lot of work over in Cambridge and had a relationship with Cambridge University. Cundall's, one of the real leaders in environmental engineering, and brought some really new thoughts about trying to remove some of the mechanical equipment out of the building and delivering that in a natural way. And Chalk Creatives for furniture, who came in and rethought and took a very big step for them to make our furniture really mobile. And the bit that's been really interesting as we've moved the project on is moving some of our leading contractors into being integrators. That's to say, taking the very, very best that industry has to offer in panelised construction, in volumetric construction, in assemblies and components and specialist made materials, and making them work together as a building, which is very, very complicated. And you really need some highly experienced top contractors to be able to do that, and we can gradually start seeing that happen. So we've got an active team now developing up further details. Every time you take a next step and you think, gosh, well, this was really exciting, we then go on to think, well, next time we're going to see these spaces being used by children, but it's still doing the same core things that this was doing 12 months ago. Climate change is sitting behind all of this, but GenZero really, really reflected the idea of creating ultra-low carbon schools that would last a long time, and schools that could be made in the UK.